Any question I want to ask?
Huh?
No question. Actually, I don't know how to. The slide I had although last week. I just put some extra partial paper. So you see, this week is already week 7, week 8. Maybe next week there's no tutorial. We haven't finished the I2C, right? When it stop? Yeah. Master transmitter, master receiver mode or something like that. Control set. Okay, register 还没讲。Same thing a lot of register, then you just use it to control the interface or that's I2C. That's why this week try the button, the RGB LED joystick, the rotary switch 1, 2, 3, 4. Temperature sensor 5. Joystick, rotary switch, RGB LED, temperature sensor. These 6 components. GPIO is very simple. You just set it. You don't need to set anything. You just read or write. Read the value or set the value, clear the value. That's all. So you just try to configure it and try it out to make them work first. It's like you need to make every component work. And then after that you can do the assignment 2. Assignment 2 is just put all the components into one. Then with some timing and so on and so forth. And next week they will cover the timer interrupt, the 60 interrupt. But this week at least you have some component for you to try. So you make all the button, joystick work. So you have a lot of components, you know how to use them. Then later you can put them together. Don't wait until last day, then you want to put all work at the same time. It's very difficult. This week you make button work, it's very simple. Actually you notice it's just one line. Actually the initialization is not useful. You notice the initial GPIO. What function number equal to 0, pin mode equal to 0, open drain equal to 0. Actually, you go back and comment it, you find that it's still working. Because the default setting is 0. All the default setting is 0. The function number, if you didn't write default setting in GPIO, it's a 0. So implied, any pin, if you didn't configure, their default setting is always 0. It's always GPIO setting. And then pin function, pin mode. If you didn't set anything, pin mode default setting is 0. Implied, all are pull out. Open drain, you set it equal to 0. That's implied. You didn't set anything, that's default is 0. That's it's not open drain. If equal to 1 means open drain. Like I2C. I2C actually, the SCL, SDA, these 2 bars is open drain. So normally actually we need to connect some pull out resistor there. I think it's in the notes. I don't know whether it counts. Somewhere in the middle. hardware. There's no circuit. Oh, GPI or in a GPI or I think he mentioned the open drain. In some way he told you that you don't need to worry about the open drain thing. He just introduced the circuit how it looked like. Oh, chapter 6 should be inside the chapter 6. You related to your accuracy. It's like the open drain. Maybe I got the. Channel 1, 2, 3. Oh. I don't have chapter 5 and 6. Chapter 5 or chapter 6, he talked about the open drain. Something related to your open drain. Yeah, accuracy is these two bars is an open drain. Anyway, this week, maybe this Sunday, you go and try to let the button work first. Or if you bring your laptop, you can try it out. It's not something difficult. At least you record now how to make all these components work first. So you have a lot of components. Later you just copy and paste, put them, each component put together. It's easier. You don't wait until last few weeks, like until this period. Wow, got interrupt, got this thing, got that thing. Wow, everything want to put together. Then you still don't understand the manual what it's talking about. Then yeah, you find it very difficult. Like this week, you just accumulate the things, try to make one component work first. Later, you just put them together. Yeah. Then later, you just handle the interrupt things to coordinate the timing. How to let something work first, then the other one work later, so and so forth. So, more after that, Chris will take over. So the 10 will be there, 17. Anyway, I think this thing I already go through last week, so just fresh. Okay, of course you need to download all this thing. Yeah, register part quite important. R0, R12, R13, stack pointer. Same as last week. Okay, I think I just roughly go through. I skip this or this to then later we talk about the past year paper. R14. If you have any problem, just let me know. Just stop me. R14, program counter, special register. Okay, this one, yeah, NZCD, -0 carry overflow. They haven't come out in the, I think, exam. I can't find any exam ask this about this thing. Just take notes. Interrupt. This one exception number interrupt. You will learn it after I2C. When you learn the NVIC, nested vector interrupt controller, you will use this. They'll talk more about this exception number. Yeah. Then next week lab, I think you will use this 60. You're going to use this 60 system tick timer. This 60 interrupt. 60 interrupt. Actually you use it before, but you didn't notice. When you run there's a Blinky program, right? You remember the Blinky program? One of the Blinky program, they are using the 60 for the time delay. You can go back to find the CM6, there's a CM6, I forgot, what, MCU Blinky. You can go back and find something like that. the program they're using the 60 to make the delay timing. Yeah. The rest, there's one use a for loop. There's one plan C is using the for loop to create the delay. There's another one that use a 60 interrupt. As in you turn on your LED, but every 1 millisecond they will go to the 60 interrupt to update the timing, to update the tick. There's an MS tick. Every 1 millisecond they tick. Every 1000 they switch off your LED. Every time the tick more than 1000 they will try to switch off the LED or switch on the LED accordingly. So 60, the idea is very useful. And then you can like play the song, you one button you play the song and said I can use a 60 every one second update my segment, or every 1 second I go to up. I think according to your assignment 2, it's like every 2 or 3 seconds. 2 seconds you need to check your light sensor value or temperature sensor value. Then yeah, but you can do other things, because to do the light sensors read the value it takes few milliseconds. You don't need to hold for 2 seconds, 3 seconds there. Just want to take a very short period read the value. You can use like maybe your timing is something like that. Every 2 seconds, maybe yeah, you only take very short period of time to read the light sensor value. So you a lot of free time. This period of time is free for you to do other things. Right, your microcontroller don't need to stay here and wait. So you can think about how to fully utilize your computational power. Maybe update, what else? Update the OLED. There's one requirement. Then what else? Timing, temperature, update the temperature, check the lightening, and so on and so forth. You go back and read through and RGB. That's why you need to play around with this RGB. I think that's part of the requirement in your assignment too. So this week you can try to play around with all these things. Let the red, how to turn on the red LED, green LED, blue LED, and so on and so forth. In fact, maybe you can test. Okay, then carry on this thing first. So this one, after that is an execution program status register. Interrupt. This one you also you're going to learn it in the next few weeks. In fact, in the end you find that maybe exam they will test you. Exam they will test you all these things. But when you do the interrupt, although they told you all these things, but you find that you won't be able to use it. It's all these things is in the assembly. But when you write in C, actually the library already built or handle all this job for you. I think in your interrupt, you find that the key is the last few slides. For your assignment 2, it's the last few slides. And they may take 2 hours to talk a lot of things. But in the last few slides is a key. You are trying to define the priority. It's talking about the priority in the after this I2C. But you still need to know all these things somehow. The pre-mask, fault mask, and base prime, all these things. Actually, you learn it in lecture 3. Then they will cover a little bit in the after this lecture 8. That's in lecture 9. After this I2C, they will cover this. Exam may test you. I find there's some puzzle paper that asks the question about all these things. So take notes. I believe you already forgot all this, because in the part 1 you didn't use it at all. So in part 2 you also won't use it, because you just use a C programming. You just write a line It's just like a GPIO. You notice when you use your GPIO, you set direction, you also just type set direction, that's all. You didn't go to check the GPIO, FIO pin, although they tell you a lot of FIO pin, FIO, what direction, register, and so on and so forth. The directory is this, address is this, and so on and so forth. Then in the end, it just, when you do the programming, you just write one line. Read GPIO read value, port 2, pin 31, port 1, pin 31, okay, value, then you get it, that's all. But details, because it's inside the library. Yeah. You find that the second part, all the lecture is similar. The first half, they will take 2 hours, 3 hours. I think until now you still don't know how to write the I2C, because it's in the last few slides. You can go back and find the details is in the last few slides. They teach you how to write in the programming. The first, the 80–90% slide is talking about the theory, the concept of it. Yeah, tell you that how to send a message and so on and so forth, blah 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 blah. Then what else? Send a message. I2C, they'll tell you how to set the mode. Because you can be a transmitter, you can be a receiver. Because maybe your sensor is an input sensor or output sensor. So like light sensor is an input sensor. You read the value from the light sensor, so it's an input to the microcontroller. So your microcontroller should be receiver. You try to receive. But of course, you also sometimes you maybe play a role like a transmitter. Because you need to, inside the light sensor or whatever sensor, they can have some register. The control sensor, control register. You need to set the value. When you want to set the value to the light sensor, then you will become a transmitter. You will transmit the information. Like for light sensor, maybe I can send some message, some information to the light sensor, and control to set the threshold value. Like maybe above certain value, you need to trigger some interrupt, or above certain value, your light sensor need to do something. Yeah, there's some register inside the light sensor. So you play a role like a transmitter. But when you read the value, you play a role like a receiver. So, yeah. But you find that they 2 hours not only this week, next week they will cover the I2C. Whole 2 weeks, there are a lot of things. Actually, you find that in the end, when in your assignment, you may not really use it. Because in this LPC17XX, they already do the job for you. They already tell you that how to start. I mean, you notice the initialization, how to clear all the status and then reset everything back to the default setting. Yeah, then how to stop the thing. Because you need to send the start bit, right, and the stop bit, right. Yeah, they already do the job, so you even you don't know, you just call this function, they will do the job. Then the key is like send byte. Yeah, mainly is this one, send byte and read and write, these two. Yeah. So you can go through. Actually, when you learn, like maybe they cover the I2C, I think you can refer, when they teach, you can refer all this code here. Actually, they provide the information how there's. The theory is like that. They try to see whether I can remember. I think this week what they cover. Yeah, first you send a start, is it? Then after that followed by the address, followed by start, then after that is the divide address. Right, 7 bit lah. Then followed by read or write, right? So total is 8 bit lah. Then this is the first message. Then 1 bit, 8 bit. Then next one is the acknowledgement. Maybe not send it. Master, maybe if a master send, let's say LPC 1769, send it. Then somewhere here will send the acknowledgement. If I'm not wrong, should be acknowledgement. After that, you go to this address, then you send the acknowledgement, then they will send the byte address or whatever, 8 byte. Then with the acknowledgement and so on and so forth. After that, in the end, they will stop it. Okay, no, not send it. Always the master send it. Somehow, then in the end, they send the PAL. So you can check, you can refer how the code they actually read and write. So it can help you to have a better understanding about the I2C. But in the end, you find that when you really code it, it's not that difficult. You just call the function. Even you don't fully understand how it works, you don't need to really worry about it so much. You just call the function accordingly. In fact, if you go to, did I include the baseboard source light sensor? You see, the light sensor, nothing to initialize. So this function is redundant. You don't need to write. Nothing inside. It's nothing inside. Yeah. Then after that, they enable it. Actually, you can see you also don't need to know. You just write this line, your light sensor will be enabled. Of course, there's some details. You can refer all this. Yeah, how they I2C, how they write this thing. This is the address. Yeah, 44 0x44. Light sensor. You have a schematic diagram, you can check. Light sensor address is like this. 1, 2, 3, 4, 5, 6, 7. Yeah, this is the address for the light sensor. Every sensor they have a unique address. That's why they can share. That's why they all can connect to the same. If you look at the table, actually the light sensor accelerometer, one more thing is like OLED, maybe they actually connect to two pin on it. The I2C one, is it? Yeah, you find that they all share. This one, the good thing of this I2C is they just need to use the SPA and SCL. They just need 2 pin. All the sensor, 3-4 sensor all connect to the same bus. Because every sensor there is a unique address. Every time they will recognize this address first to decide this byte is sent to which device. Yeah. That's why you can connect a lot of sensor to the microcontroller. Compared to GPIO, one pin you only can connect to one sensor, and every time you only can receive one bit, either on or off data. Become very simple and a lot of limitation. So if you got 10 sensors, you need 10 port, 10 pin. But I2C don't need. You just need two pins. You can connect to 100. Theoretically, can up to 127 devices. 7 bit 7 bit 2 power to 7 lah. So yeah, theoretically, you can. The maximum number of devices you can connect to is 127. Anyway, you find that when you really code it, it's quite simple because there are a lot of library. But exam, you better know the concept. So you better go through it to have a look for more details. Like how to enable, how to read the value. You can always refer this. Yeah. For this thing, yeah, next week you will learn all this. But it's good you better download. I think last time I also told you all that go and download the data sheet. Like light sensor. If you want, you can print out them if you want. But actually the sample code is there, so you don't need to really fully understand the details. But the information is here. You can set the range, you can read through something like that. Actually you need to, when you really implement a sensor to communicate with the microcontroller, you need to know how to read the data sheet. Of course, this one they already built the library. Someone already do the job for you. Here. So, but you can somehow refer the details. Actually, that's the first step. If you want to configure a sensor, the first step you need to somehow understand why I know. Blah 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 blah. Threshold. After that, you can find that interface address is hardwired internally as 1,000. 1,100. So 1,000. Yeah, sorry, this one. Should be this way. 4 bit. 4 bit. So this is 4. This is 4. Right. Information is here. Of course, they build the library, so you may not notice. The information, everything is here. Actually, maybe sometimes if you find that the lecture notes is not, you are not able to understand, you can refer the details here. They tell you how they read the data. Yeah, first they send a start bit, then the clock start on, off. Then 1 0 0 0 1 0 0. 1 0 0 0 1 0 0. This is the device address. First they send the device address. Then the next bit is write. They try to write something to the device. Then after that, this one is you send something, so someone must respond. I call you, you need to respond me. You need to say yes. Yeah, this is an acknowledgement. So the device will send an acknowledgement. Oh, received. Okay, then I can carry on to send further the device itself inside. The light sensor itself inside there's a register. They maybe have a lot of register. Actually, they have a lot of register. If you go down, they have a lot of register. There's a command register. Light sensor, not this one, not this one. It's this one. Light sensor, maybe somewhere here. Internal itself, there's some register, like command register. There's a control register. There's some threshold, timer, and so on and so forth. So you can set something. For example, in the light sensor, you can power down it. You can enable, disable it. Or number of cycle, the resolution. You can set the resolution. Yeah, it's 16-bit, it's 12-bit, it's 8-bit or 4-bit. To read the value, to read the light sensor value. I think normally we use 16-bit. Yeah. Then they will tell you how to control the gain, trigger the, just like I mentioned, the threshold. The threshold, you can set all these things. That's why a sensor, you not only need to read the value, just read I think read value should be below. Yeah, you not only using this tool to read the value from the light sensor. You sometimes maybe you need to send some information to set all the control register, or send some command to the register to enable the light sensor. You can see this one 0, 0. This one the register, command register is 0, 0. Then if you want to enable, you give 1. How I learn it? I try to learn it. Then I want to enable, right? 0, 0. Command, address command is 0, 0. If I want to enable it, I need to send 1, 0, 0. Is it true? 7-bit. You set it to 1, you will enable the light sensor. So if you look at here, yeah, you need. First, you give the address 44. Second one, you give 0, 0, command register. The third information you need is the 7-bit equal to 1. The light sensor enabled. Then you use the I2C write. Basically, they will send a start, they will send the 44, then the device will give an arrangement, then they will send the command register 0, then after that they will send 1, 0, 0, 0. Bit 7 is 1, then they will enable the light sensor. Roughly that's the idea. So you find that actually you don't need to really know how to I2C write. They already do the job for you. Yeah. But you find that all the peripheral is like that. There's a big library under CM6. Yeah. Under the library MCU, all the interface, how to read or write whatever things have been done. Same thing as a GPIO. GPIO, you also don't need to worry so much when you implement. You want to set direction, you don't need to know the address of FIO direction. They will get the address for you, they will update the value. You just give the port, you give the value, then tell me the direction. Yeah, that's how we set all the interface, GPIO. It's because we have this library MCU. Otherwise, you really need to understand whatever you learn in lecture 7, lecture 8, and then you need to write in assembly yourself and so on and so forth. Yeah. Roughly, that's the thing. So this part you will learn it in the next few weeks. Just take notes. They may test you during exam. But you find that for your assignment 2, you don't really have to know exactly how to configure it. You find that in the end, only the last few slides is very important for your assignment 2. Yeah. Then control, yeah, just remember it is a 2-bit control register and so on and so forth. Exam may test you, but you have no way to use them. So this is all the register. So that's so far what you learn. Yeah, in lecture 1 to 4 is you use this portion. Later interrupt, actually you will use this portion. The first few 256 words. But I think the microcontroller you have, they only use about 35. Only use 35 vector. They don't fully use it. Only use 35 interrupt. There are only 35 interrupt inside. Yeah. Then last 2 weeks you learn the GPIO, so you use this thing and this part, thing select and this one. Then this week, what you learn, you read, you see the control set register, what they just cover in the end. Yeah, you notice the address is like 4005 C00. One is here. There's one more is here. And then there's one more is here. Right. The lecture notes cover 4005 something. Controls I2C control set. Right. 4004. Right. Or this one 4001. Or the one 4008. Okay, you somehow know. You don't need to really remember the number. As I said just now, you see, you never use the register at all. You just check the value, just set the value accordingly. So you just somehow know all these locations, so you get a picture. Yeah, roughly that's what I learned so far. The rest I don't need to know. So assembly part, because you need to know how to. Yeah, this one mainly for exam, you need to really know how to write it. So, yeah, you need to know how to load, how to move, how to add, subtract, multiply, add, divide, compare, branch, if, then, and so on and so forth. Yeah. Always I think for exam only they assume that the data is inside the memory or inside the register. What you need to do is like just load the data to the register and move or do the extract, subtract, multiplication or compare, then in the end store the result back to the memory. Yeah. So normally first step you don't need to worry. You need to know how to load the data, how to do all the algorithm calculation. Normally the question quite simple. The mathematics part, it just give you an equation, you just write accordingly. Okay. Same thing for this carry and overflow. You just remember carry is whenever you cross this line, there's a carry trigger. Whenever you cross this line, you will trigger an overflow for cited number. Okay, this thing is covered last week. So if else statement only can support up to 4. If you want to do more than 4, you need to do the branch in the last line. Only the last line allows you to do the branch. Yeah, as I mentioned just now, all this library is very useful. Library CN6, especially this library MCU, they provide all the interface you need to use to read or write or enable, disable initialization and so on and so forth. You can find all the details inside. Yeah. Same thing for the keyboard library. They provide all the sample code. So if you want to learn GPIO, you can refer joystick.c RGB.C. But this one there's a mistake. Take notes. RGB.C, there's a mistake. Let me show you. RGB.C. You look at this one. Yeah, I will correct. You know why? I think in your PC you go back and see this is what you have. You know what's wrong with it? There's a mistake. Yeah. Any idea? These three lines, one of them is not correct. Any idea? You know why? Why? You know why these three lines? Why the first line? Okay, first line. Why first line is not correct? If you check the table, you notice this one should be RGB. If I'm not wrong. Blue is port 0, pin 26. Port 0, pin 26. This is a blue. Then set the direction for the blue, which is the output LED. Then port 2, pin 1. Port 2, pin 1, this is green. This is red. So if you use this one to run, you find that you won't be able to see the red LED on. The red LED won't be able to on. You know why? Red LED is connected to port 2 pin 0. It's connected to port 2 pin 0. So you should put 1, not 0. Yeah, this one. You go back and check, your code is 0. The library is there's a typo, there's a mistake. They give you this. Actually, this is not correct. It should be 1. It should be 1. 1 means port 2 pin 0. Very hard to understand. Maybe I write this way to be clear. Okay. Port 2 pin 0. You shift left 0 bit. Of course, no change. If you port 2 pin 1, port 2 pin 1 means that port 2 pin 1 means that this one should be port 2 pin 1 10 means 16. You can put 16. Or you put this way. Port 2 pin 1, this one port 2 pin 1. But not 0. If you put 0, I think you remember this week tutorial, right? You put 0, they won't do anything. They do nothing. They only recognize, they only update the bit with 1. The pin which is given is 1. Then they will update it to 1 for that particular bit. So if you put 0, they will simply remain unchanged for all the 32-bit data. That's why you can write, sometimes they write this way. Some people want to remember, then they just write this way for consistent. I think it's nothing wrong. You can write this one, you can write it as 1. Also can. You can write it as, I think, or x1 also can, up to you. All are same thing. You just feel which one is more convenient for you. Just take notes. Yeah. So that's why you better go back and try out all the sensor. Make sure you know how to use the button. Yeah, you know there's a mistake here and there. Make it work. Every component make it work first. Then later you just think about how to combine them together. So this is the base course. Okay, of course you need to do all the number conversion. This one already mentioned. You also learned it in 2020. Maybe we try some past year paper. This one I didn't give the answer. Go and try. I think you better try it now. Give you some time to try it. $25 marks. You try to use paper, take half an hour to finish it up.
what you want actually.
Which one not understand?
Yes, like what the question want actually? Is it just the formula and then or
They give you the formula.
it's
It's
given
given.
we have already.
They give you the formula. they said it may be useful to use it then. You need to find the nearest one. Of course, you need to use the it then. Otherwise, how you know which one is the smallest one? Don't have log now, why you all go use the LOAD? First step always is log the list. You understand the question, right?
I don't really understand.
He said it's like there's a point P with coordinate. A point P with a coordinate SP, YP. Right. Here. To find the nearest object from a point P with coordinate X, P, Y, P. Then there are n objects Ci where each with a coordinate 1, 2, 3. Example. Xc1, Yc1, Xc2, Yc2, Xc3, Yc3. Then they ask you to find, using this formula, the square distance, to find the distance, between the XP and the XCI. Between XP and XCI. So you need to find the shorter distance among all these, and then to indicate whether 1 or 2 or 3, object 1 or object 2 or object 3 are the nearest one. Yeah, which one is the nearest one? So they already told you that
This is what?
R8 and R9, whatever number,
Fixed, right?
it's just an example. Anyway, you just assume R8 and R9. There's a XP. This one is what?
XP.
XP. This one is XP. This one is YC. Yeah. Okay. This you assume is given. You don't need to write any code for it. Assume it's there already. Then in the main memory, there's a NC, CX, CY. NC is the number of objects. CX and CY is the pair. All the X coordinate and Y coordinate. Okay, then ask you to write the program, an ARM assembly language program. So first step, I don't have a solution. I don't know. Of course, I have to load all the information, all the data from the memory first. So that way, I need to use one of the resistor to load NC. So I got the number of objects. Maybe 3. This one is just an example. It may be 3, maybe 4, maybe 5, doesn't matter. I got the start address already. Then, of course, somehow I need to know the R1, R2, CX and CY for sure. Later see how to use it. At least like that, maybe can score 1, 2 marks. Better than nothing. No more. Okay. Then next is like I need to do the calculation. So I need this one subtract with this one subtract with this one, then find out the things. So you expect you need to do a lot of times by calculate the square distance. You expect you definitely need a loop. Right.
Yep.
Then somehow better you need to like BNE loop. I don't know what it is, but it definitely depends on the R0. R0. Anyway, this one thing should be something like this. Should be something like this. I don't know whether it's correct or not, but you need to run every object. You need to do the subtraction, every object. So you definitely need to load. I need to LDR load something R3 with R1. I load the first number into R3, XC1. This is YC1. Then R1 will plus 4.
Minus 4. Plus 4. Plus 4.
Yeah, S1, R1 will be plus 4 after that. This one will go to R3.
The next one.
This one will go to R4. Then R2 will plus 4.
Address.
Yeah, address update. So later then look, I can take the next number. Okay, you got R3, R4, you got R8, R9. Then you look at the formula, just do accordingly. Subtract R3. I think I need another R5, R3 and two R3 and R8 is it?
Or R8 and R3. R8.
Doesn't matter. Later you multiply. Who minus who? Later you also add, you do the multiplication.
But later will come out minus or not?
No what? R5 times R5. Negative still positive.
Oh,
regardless is R3 minus R8 square or.
Yeah, you will be positive.
Yeah. So after these two lines, it's positive. Maybe this one need to shift now. Then you subtract R6 maybe. You subtract R4 with R9. Then you do the same thing. R6 and R6. So they do the multiplication. Then you sum it up. You add. Maybe for way R6, R5. So R7 is the square distance. So basically this is calculate the distance. Then later I try to stop finish it. Probably this one is already 10 marks, I guess. 1, 2. Maybe 10 marks, I guess. This one maybe 2 marks, 3 marks, something like that. Not any yet. This one, yes.
R0 and C, what I need to do I don't know.
This is the address. This is the address. Oh, just not. This one just not correct. Not very correct. So I need to LDR
R0, R10. R10, R0. Bracket R0.
Maybe something like that. This one is just an address. Then in this one you get the number. Or maybe you confuse. This one I put another one. 8, 9, 10. Yeah, maybe.
Why cannot spread? No need the equal sign.
Cannot syntax error. You cannot put NC on. I don't think you can get the result. NC is the address. Is the address. I don't know. This the location here, the address here. So you put equal is like you assign that address to R0. Not a number, not 3. It's something else. 100 something, 1000, 8000, something like that. Or 1000, 7000. This one, then I almost use up. Then I store this. I think I need one more. LDR 11. One way is this one. I put OF for R11. Then I compare CMP, compare R7 with R11. Then IT, which one now? Which one? Less than.
Lower or same?
Lower, LO, lower or same. LS or LO, I think it's okay. If equal, I think he didn't set if two numbers are equal, what, how? Did he set any? Did he make any assumption? Consecutive identity per word. Okay, never mind. We just use the LS. Then, if less than equal, that means I will move LS R11 to R7. If I compare these two numbers, this is the largest number, right? Cannot be more than that. This one I compare with R7. R7 is the distance, the first object distance. After I do all this calculation for the first iteration, R7 is the distance, right? Then I compare, of course, R7 definitely smaller than this number, no issue. So you update your R11. So now R11 will store the distance of the first object. Okay? Then you try to subtract SUBS, subtract S with the S R10 minus 1. Then I try to BNE not equal to 0, back to the loop. So, does it work? If it's 3, now it's become 2. 2 go back. 2 is not equal to 0. So go back to here. I load the second number. I load the second number. I load the second x, second y. And then I do the subtraction, multiplication, subtraction, multiplication. I sum it up. Then this is the distance of second object. I compare the distance of second object with the first object. If it's less than or same, then I update.
If you don't use compare, can just
if you don't use compare, what else you can use?
Just because R7 already will definitely move to R7. Right?
Not really. Second object may not.
Then after you use
second, when you compare second object, may be true, may be false. Depend this distance is shorter or this distance is shorter. This one is not only for compare the first number, not only compare this number. It's every loop you need to compare.
Why must compare F?
This is the largest number. I need to give an initialization. Otherwise, first object, you have nothing to compare. If I compare with the largest number, for sure, you cannot have a distance larger than this number. This is the 32-bit. If it's out of the range, then that is the lecturer problem. Right? The largest number, no matter you do this, this one cannot be more than 32-bit. If it's more than 32-bit, you are not able to handle it. Or you need to write more complicated. It should make this assumption. Yeah. Of course, there's another way. There's in the first object, you do it once. You do the calculation outside the loop first. You get the first distance. Then from the second object onward,
Use that compare.
you use the compare and then run the loop. Also can. Yeah, but exam don't have so much time, right? Then otherwise you need to write this one once outside first for calculate the first object to get the first object distance. The idea to find the nearest distance is like I calculate this one, I get a value d1. I get d1. Then I assume d1 is the smallest one. Then I calculate d2. Then I compare d2 with d1. See which one is smallest. Then that's it. My R11 is D minimum. First time I put R1. First time I put R1. Then I run one iteration. Second iteration I got D2, right? Then I check D2 with which is D1. Okay? I compare D2 with the D minimum. I compare D2 with the R11. If this one smaller, if D2 is smaller, then minimum is equal to D2. Else, D minimum remain unchanged. No change. Right? This is this part trying to do. Similarly, when I calculate D3, then if it's maybe you update, maybe you not. Maybe this one, maybe either D1 or D2 previously. Then you compare again. Then it may become D3 or remain unchanged. So it's a loop. You keep looping. You got the idea? Every time you compare the smaller number, you add in. It's better. Of course, there is another way. You do all the calculation. You got 10, but you will face a problem. You got 10 objects, then you need to use 10 register to store the distance, and then find the smallest number later. But that is not a very good approach. I think this way is better. Every time you add in one new number, you check whether the distance is smaller. Smaller than the previous result, then that one probably is the smallest one. Then you keep store the smallest one. After you finish the loop, the number you got, that is the smaller distance. This is the nearest distance. I think may not enough because this one not end yet. Because the nearest result is the number of objects. So I need one more resistor. ITT. Then move LS. If it is true, that means I need to store the number. I need to store the number. I need to store the number. How to know the object number? I use this one, then very hard to know the number. If I store this one, R10 LDR R10 equal to start with 1. Object 1 means 1. Then this one R12 move the R10. Then I need to let ADD R10 equal to +1. Second object, third object. Then compare R10 with R0. much with I need MI. Yes. Why? Because nearest the number should be the object number, the object number. So how I modify? Now I store R10 with 1. That means the first iteration you calculate for the object 1, right? So if it is true, of course it definitely is true. So you will store the R10, the result, to R12. R12 is the final result. So in the end, I will str store R12 to nearest. Okay, I didn't load nearest. Okay, never mind. I try to load nearest. LDR, the nearest. Never mind, I can use any one. R3 is no longer useful. Nearest is any one. Nearest to graph. NEAR nearest. Then STR R12 stored in R3. That is the result. You got it? This one, object 1, start with object 1, right? Then object 1, I will, if this is true, I will update the object, I will update the R12 result. Okay, we try again. Now you load the number, you load the CX, you load the CY. Okay, then I try to load the number. This one is just an address. But this, after this, R0, I can got the number of object. In this example, 3. In the example, R0 equal to 3. After this step. So, then this one, I put the largest number. I put the largest number first. Definitely is the largest number. Then, now, I'm going to run the loop. I'm going to consider the first object first. R10 equal to 1. I consider the first object. The first object. That's in 2 and 4. I'm considering the first object. I'm calculating the distance between the first object and my XP.
When you say equals to 1 means it's the first address.
Which one?
Load 12 equals to 1.
Which one?
Load R12, comma equals to 1.
Look,
R10.
R10 equal to 1, first object. 1, I'm looking for the first object.
So 1.
I put 1 first. Okay, then I load R3, R4. Okay, you load the 2 and 4. In this example, 2 and 4 will load into R3 and R4. Then this portion will do the distance calculation. From here all the way till here is the VI square. You subtract, multiply 8 is a distance. R3 minus R8, R3 minus R8, then do the multiplication, square it. R4, R9, R4 minus R9, then you do the multiplication, square it. So it's the square distance. Then you add it, you sum it up. R6 and R5, you sum it up, you put in R7. Then you compare R7 with R11, the largest number. Of course, it's true lah. For the first object, no problem. Definitely less than offset. Definitely less than that. So you will update R11. So now R11, after first iteration, R11, the number will be the distance of D1, right? This one will be stored the D1. Okay? So, of course, you will put 1 R10 is 1 ma? 1 object 1 into R12. R12 is my final result. So now, after first iteration, implied that I assume object 1 is the shorter distance, is the nearest distance. After first iteration. Then now I'm looking for object 2. I add R10 with 1. So I'm looking for object 2. Then I compare R10 with R0. R0 is the total number 3. Now it's 2 ma, not 3 right? So still can carry on. Not negative. Mi is minus. Minus is not negative. You look at the table there. That's why I said you don't need to remember this table. They will provide you negative, not negative, right? Okay, I have to carry on the loop. I'm loading the second object, the x and the y for the second object. I do the calculation. This time I calculate the D2, object 2. Okay, this time I compare again. R11 just now store the first object distance, because I assume the object 1 is the shorter distance. Then I compare with the distance 2. I compare it, see which one is smaller. Let's say, for example, if D1 is the smallest one, if D1 is the smallest one, then you will not update, remain unchanged. R11 and R12 remain unchanged. You still store the D1. If your D2, I think in this example, D2 is the nearest distance. So, if D2 is the nearest distance, your R7, which is D2, right? At this moment, after second iteration, D2 was stored in R11. 2 was stored in R12. 2 was stored in R12. Then you will add 10 to 3 plus 1. Now become 3. You're going to run the third iteration. Then you compare with 3, compare with 3. Still not negative, right? Still not negative, right? In this example, not negative. Okay, you load it again. You load the third object, third distance, 5 and negative 3. 5 and negative 3. You will load 5 and negative 3. You do the calculation for D3. Then you compare D3 with R11. If less than or same, in this case, I think D3 is greater than D2. So you will not do any updating. So you still remain R11, still remain D2. R12 still remain 2. Then you plus 1, this time become 4. 4 is greater than R0, so you will get negative. Then you will stop the loop. Then you try to load the nearest distance, address R3 equal to nearest, based on the question given. Then you store str, store R12, which is D2. No, which is 2, which is 2. In this example, is 2 will store inside R3, which is the nearest distance, which is here, this location, 2, finish. Of course, remember, provide a short description of what each register is used in your program. That R0 is this, R1 is this, R1, blah, blah, blah. Yeah. Still got marks, maybe 5 marks. Yes?
The memory is used dot word.
You assume they already do the job for you.
But I want to know if
you want to define, I think, how they, I don't know which one they give. Maybe NC is dot word. If you want to define, this one is fixed. Yeah, this one is for constant, no? This one is for constant. Of course, I also can define dot lcom. Dot lcom nc 1 byte. Then I try to load the number. I try to store the number. I try to store the number into it. Also can. Yeah, but that's why I said just now. I told you. Normally the question you notice, tutorial also. You don't need to do all these things. They did ask you to do all these things. You assume they already somehow put into the memory, they somehow put in the processor for you.
Because in the assignment I used dot word multiplication factor 10k.
Yeah.
Then I didn't use the equal sign. That can work. Look. Multiplication factor, then can go in.
Or you just put the number.
Yeah. I don't need put equal sign.
Is it? I didn't try that. Maybe. But normally they write this way.
Yeah, so I was confused.
You just put this way.
Uh,
Is it what? You can try. I didn't try that way. So. N, is it? I got N here. I put N. Oh, can I? Yeah, there's one here.
yeah. So sometimes I confuse.
Yeah.
So if you put below equal means it's the address also.
Okay, you don't put, then you directly get the number.
Just
Then you don't need this line. Yeah.
Where is the line?
You put NC means you load the number directly.
Then the address
The address, I think you need to do this.
equal.
Yeah, because later you need to shift. It's not only, you not only interest on the first number, later you need to plus 4. So you need to know the address here, not just the number here. You need to know the address. This one, okay, only one number, 3, fixed one. So you can directly use it. But these two cannot, because you need to get the address. Otherwise, later, these two steps you need to update. You don't know how to update.
Okay, the load R10 equal 1, I can also use move R10 1.
You also can put move.
Can also, right?
We also can use move R10 1. 1.
1. The number 1. Hex
Yeah.
1.
Also can. But this one cannot. This one cannot use move. Because you need to load 32 bit data. Move only up to 8 bit. Move W only up to 16 bit. So this one is better. This one is the pseudo instruction. When you compile, actually you check the code, actually they will try to convert this line also using the move W or move T to load the data. That's why you read the lecture note, they say this is the pseudo instruction. It's not really the real instruction. When you compile, they still convert it to some other instruction to fulfill what you want. Yeah. Roughly, I think this is question 25. Yeah, you have to finish it in half an hour.
See, the difficult part right, is want to know what the question was. That's what I mean.
Yeah, that's why I already somehow highlight to you. I think exam, you can see normally last week I also show you one question. This week also you can notice normally you don't know at least you try to load something first.
Oh.
Better than you let it blank.
If you write anticipate the formula, get half the mark.
Or you just try to somehow write this portion somehow write
yeah.
maybe incomplete. Better than nothing Still got some marks I think. You let it blank for sure 0 marks You write something maybe incomplete, still got some marks. Of course it's good you can finish it but I find that you better use pencil because every time somehow you need to halfway then you find hey I missed one thing you need to squeeze something into it. Yeah. And yeah, the rest I also don't know how to tell you because for sure they would ask this question again. But you find that every year the question he asks, the style is very similar. Always like blah 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 blah, I give you a formula. Then you maybe somehow they force you to use an if-else statement. They force you to write a loop. Then in the end you need to learn how to store the data in some format. Yeah.
But to understand the question take time.
Yeah, depend, yeah, true. This one or it's quite okay already.
It's quite okay.
Because hello, I got others. Yeah, you can see this one also. Maybe this one easier. I think this one easier. This one easier. 15 marks like that. You want to try? This one should take 15 minutes to finish it. Already give you an example. You just follow. You find a similar one. Every year the way they ask, more or less similar. Okay, maybe 15 minutes finish it. Well, the answer is just for your reference. I'm not too sure whether it's correct or not.
Correct.
You want, you can quote it. I think last week the one I give, after that I find that there's some mistake. You go and check yourself. Actually, quite simple. You go back and use the assembly, like just now the one, you use the assembly.
Keyback.
Yeah, basic, right? You run it off, you just type in.
But I have to define all the alcohol.
Maybe you need to define some number yourself. You need to load some number before that. Yeah, to try it out.
So, but before exam, the board already written, right?
Before
I
exam.
mean, the board.
Yeah, after assessment
So
they will ask you to
So we
return.
can't try at home.
You can request You can request them. I think can return letter if you want. Should be okay. I think they are okay too. You can return back letter. Yeah, you have to return back before you receive the grade. Or then you just fill you, then that day will return back.
The integer R, A and N, that one is R0, R1, R2, correct?
They give you the function lah. R is R0, A is R1, N is R2.
R is?
It's same as your assignment 1 lah.
Oh, yeah, right, correct lah. R0, R1, R2, correct lah.
Yeah. It's also test your understanding because you did your assignment 1. Close book. Close book. Remember, you have to practice lah. If you don't practice, next very soon and now is October. Next one is exam. It just said you need to calculate the R power to N. That term you need to use a subroutine power. Something like what you did in your assignment 1 lah.
Oh. So they multiply per program. So they see N is equal to 5, R contains 5 times of
n is incremented in the C program.
Yeah, it's given by the C program. You don't need to care about it. You assume the number is given. Same thing. You find that always they assume all the data parameter is given, either in this way or just now something like that.
I mean, we don't need to increment the n.
No need. The n is fixed. They ask you to do the calculation on it. It's given. Yeah, this one is EQU1. This one is predefined. What this thing means, they're saying that when they compile, they will put this 2 million. Yeah, 2 million. They will replace 2 million. Any word inside this code with the LED, they will replace by 2 million before they compile. This one is after they compile. After they compile, they load the data. When they reach this line, that one is like when they compile this assembly code, they will already replace the number. What the dot EQU yeah. This one, then after that, the LD R0 you write this one, then you go and compile it. When you are compiling your program, the compiler will replace this one directly before you run it. When you compile it, they will replace the number. This one, no. This one will keep it there. When you run your program, when your program is running, not compiling, running, this one is running, then they run the thing. This one is compiled. Yeah. So they say predefined, it's a predefined confirm. This one they call it predefined constant. Faster. Yeah, this one faster because it's before that. More efficient. It's better. It's just convenient for you, for your convenience. Whenever you use this number, yeah, you replace by this word. This one is starting with the move or load. It just replaces the number.
I mean the
Efficiency. This one is when they compile, they already do the job. Whatever you move or load is when you execute the program. When you're running the program, they load the data. This one is before that they already change the number. They just simply change this constant. It's something like C. This one is equivalent to the C. You use the define L E yeah.
So if I use
Yeah. You see, it's better. Yeah, more efficient. That one, you no point to keep the data. You no point to store the data. This is just a number.
then compare this to move.
Also, this one better. This one is before they compiling the program, they already do the job. Done. So, should be.
CMP compare if let's say that two numbers not the same? Is CMP.
CMP compare R0 with R1 means that
If not
you try
equal,
to subtract R0, R1. Same thing. Then what's your problem?
then how you want to go to next slide? Then go this BMI.
This one after compare, this line we're trying to update your NZCV flag. Negative 0 carry and overflow. Then maybe later you can branch, you can do the if L whatever. Then you can add in the condition you want. You know, condition you want. Because this line will update your NZCV. So next line, you can branch or if L statement, you can check the NZCV flag to decide whether you branch it or your if L statement is true or false.
Equal to yang bawah, they keep times.
Yeah. The difference between compare and subtract. Compare, they really compare. The result, they will discuss. This one, after they do the subtraction, they will update your R0. Your R0 value will be changed after this line. But this one, after they compare, the R0 minus R1 result will just simply discuss. They just throw it away. They only try to update the NZCV flag. That's all. So that's why you always need either something with the N with the S suffix or use a compare before you do the branch or before you do the IT. You can check the notes or whatever tutorial or the example before the branch of IT. They always try to update, use the compare or subtract S to update the NZCV flag. You must update, otherwise the branch cannot check whether it's greater, lesser, or negative, or positive, or whatever. Okay? Yeah. Okay, for this question, you know that R0 is in R. R1 is A. R2 is given. This one is given. All this is given. They ask you to write the code. Then you need to write a subroutine. Of course, you need to do the S divide. While the instruction do the unsighted. Because it should be S divide because the number can be negative. Right. This geometric series, no one said geometric series cannot be negative number. Can be negative number, so it's good to use the S divide, sighted divide. He said, but I think he didn't say anything. The assembly instruction to do the sign division is S divide. What the instruction? Yeah, he didn't say you have to do which one, but common sense you should use the S divide. So I think they already given you all these things. You are going to write this geometric series, this assembly code. Inside this assembly code, somewhere, I don't know where is it, but definitely you need to BL power. Then definitely you will have a subroutine power. Then there's a DXLR. There's a DXLR to go back to your main function. This one is go back to your main C. This one is go back to your main routine. Yeah, this is roughly the structure you should have. Of course, common sense you should do the push R14. Before that you have to pop it back R14. And something before that, all these other whatever you're going to use.
Sir.
Yeah.
If we pop to R15 straight, it will be faster.
You put R15 here, you don't need to BXLR. Because you put R15, you directly go back.
Then will it be faster compared to BXLR?
You just set one line only.
Yeah.
Faster or not? of course faster a little bit lah. I think that one they didn't, it's not compulsory lah. Yeah. Because normally we put it symmetric, it's easy for us to do the debug better. Then what do you need to do? You got R, you got A, you got N in this, all these things. Then you just do the calculation. Actually I try to BL element power. I will branch to this power to do the R power to N. To calculate the R power to N. This one definitely need to run a branch. So I definitely need to multiply. I got N. I need to know N. Then I need to use the R0, this one and this one. Then N tell me to calculate the thing. So R2. Maybe I move R3 to 0 first. Then I multiply something R4, R0 times R0, no, R times R0,
R3 was the 1.
I think I need 2 0. Move R4 to 0, move a 0 to R3 and R4. Then I multiply R4 with R0. This one means that R4 equal to, this one equal to 1. R4 times R0, which is R4 times R. Okay, then add it into it. Then I check branch B. I check. I need to compare. I need to ADD 8 R3 by 1. Then I compare R3 with R2. Then branch B not equal power. Is it correct? Then I come here. Oh no, I have to before that.
Should the R3 be 1?
Cannot be power, cannot power. Should be here. The loop. I need one more label. Yeah. Then I multiply again. First time you call here, you get this one, right? It's 1 times R, right? Then you R3 plus 1. R3 become 1. 1 compare with N. Then not equal, right? Not equal, you carry on. Carry on, then this second round become R times R. Because R4 is R, then R times R, second iteration. Then you plus 1. Then you compare again. Not equal, carry on. Not equal, carry on. When they are equal, that means you already run N times. Let's say my N equal to 3, for example. We test whether it's correct or not. You BL power, you do the BL power, then you come here, you move 0, you move 1. First iteration, R4 is equal to R after this line. Then R3 plus 1. So R3, here R3 is equal to 0. After this step, R3 is equal to 1. Then you compare, not equal to 3, so you carry on the branch. Second iteration, R4 equal to R squared, R times R. R3 will become 2. Then you compare, you loop not equal to 3, carry on. So third iteration, in the third iteration, R3 times R3 times R again. Then you plus 1, so R3 equal to 3. So you compare R3 and R2, compare R3 and R2, not equal, this time equal, cannot carry on, BXLR, come back here. So you got R power to n. In R, the number will be in R4. Correct? So I finished the subroutine power. Of course, for completeness, based on you learn in the assignment 1, you should know that you should push R3. R3 you're going to modify. Yeah, R4 you want to keep it. Then you pop back R3. BXLR. Then you go back here. So now R4, you got the number. You just subtract R4 by 1. This time. I need to subtract R0. Subtract R0 by 1. The denominator. Then I multiply R4 by A. R4 by A. A is R1 by R4. Then I S sign divide. R0 denominator is numerator is R1. Denominator is R4. R0. R minus 1 ma. R4 minus 1 multiply R1. Yes. Then I pop back. So here, this portion, what did I use? I modified R4. I modified R0 cannot touch. So R1, I have to push R1 and R4. I have to pop back R1 and R4. Then BXLR. Should be answer. So you see, I try to run 1 times. I push R1, R4, R14. I go to BL power. BL power will calculate the R power to n. BL power will calculate the R power to n. Then this line subtract by 1. That means R power to n minus 1. This one is R0 minus 1. R0 is R minus 1. R1 multiply R4. That means this line is A times R power to n minus 1. Then the last line, this line is A times R power to n minus 1 over R minus 1. I store in R0. And then BXLR return R0 back to main. I got the answer. Of course, I have to push, then I have to pop back R1, R4. That's all.
If your CMP R3 and R2 right?
Yeah.
If CMP R2, R3, is it the same?
R2, R3, if you do the other way, it's just like R3 minus R2 or R2 minus R3. In this case, I use not equal, so should be the same thing. Equal or not
If
equal?
you minus, it will be negative, right?
Not equal ma? Equal or not equal ma? Negative also not equal ma?
So it's the same actually, no difference.
Yeah. It's just like just now the question, you can look at, I think actually they provide the table. I didn't include in that question. They check the Z one, the flag, 0 flag. So even you're negative, you also won't trigger the flag, the Z flag. You only trigger the negative flag and they will ignore.
Okay.
So it doesn't matter R2. But how you select this one,